we're trying to incentivize everyone in the network, but at the same time solve all the problems with like the traditional way of fetching the information. This is actually something super interesting in the Cosmos space actually, and we're partnering with like a lot of big name validators right now. Because we have two different validator sets, we can kind of always fall back on the consensus layer to reach consensus for the second validator set. And the second validator set runs the side process, which then connects to all these blockchains and pulls down the information and then validates it to make sure that it's correct.
Welcome to the Bare Metal Podcast.
Hello, everyone. Welcome to the Bare Metal Podcast. In the beginning, I'd like to customarily remind everybody that there's the Gateway Conference in June, 3rd to 5th June in the beautiful city of Prague. If you're at all interested in Cosmos or software development, please come and join us. Today with me, I've got John Letey. Welcome, John.
Hey, everyone. How's it going?
So, John is a co-founder of the KYVE project. Can you tell us more about what KYVE is?
For sure. To summarize it very briefly, we're building a massive decentralized data lake. Basically, what that means is we're taking data from a lot of major L1s and L2s. This can be anything varying from a very simple just block and transaction information to more complex things like EVM traces or smart contract events. We take all that data, feed it through our Cosmos SDK-based layer 1, which then validates that data, ensuring that that data is actually correct. So if we have the correct Solana slot 100, for example, before then permanently storing that on one of our storage providers like KYVE, for example. So yeah, that's kind of a brief summary of what we're doing.
So, I mean, not many blockchains focus on data. This caught my attention. So why did you guys decide to focus on the problem of data? And what caught your attention here?
Yeah, it actually kind of fell into our laps naturally. So like just for some personal background information to myself and then also my co-founder Fabian, we were both actually very early into the KYVE ecosystem. So KYVE is a permanent storage blockchain. And so I joined the ecosystem back in 2020, same with my co-founder. Back then, the ecosystem was very small. So there's definitely lots of potential, lots of side projects, lots of cool things that you could work on. Worked on a lot of various things inside the ecosystem, helped a lot of projects that you see kind of in the global crypto space like right now, helped them kind of, build out their initial proof of concepts. And then, it was kind of right when, KYVE was gaining a lot of traction in kind of the broader crypto ecosystem because of the NFT boom. Because, of course, you want your NFTs to be stored permanently. Was when kind of this caught the attention of Polkadot, actually. And so Polkadot approached Sam Williams, who's like the CEO of KYVE, and they said, hey, listen, like we have a problem, and it's not just a problem with Polkadot, it's a problem with a lot of other proof-of-stake blockchains, where basically these blockchains produce a lot of data. And the problem is that a lot of the time validators in the network, there is no incentive for the validators to store historical data, right? Of course, they need the latest state and they need recent information to kind of help create the next few blocks in the network. However, like historical information from even like a few months ago is not actually incentivized to store. And so Polkadot came to KYVE and was just like, hey, listen, let's co-sponsor a bounty where, we try to get people to permanently archive historical information from Polkadot onto KYVE so that then, instead of having to talk to the Web3 Foundation or Parity or anything like that to fetch, like historical information about Polkadot or having to, talk to Coinbase Cloud or something like that, they can kind of just fetch it from, like a permanent storage layer like KYVE. So, they created this bounty on Gitcoin and, me and Fabian were the first ones to kind of look at it and then also complete it. So we had a full working demo that we kind of displayed to Polkadot and they're like, wow, that's really valuable. And then Sam from KYVE also saw that and they're like, hey, listen, like guys, this isn't just a problem like with Polkadot, and a lot of other chains seeing this have actually like approached us and like want to work with us on this exact same solution. And so like we immediately got introduced to a lot of other major blockchains like Solana, Avalanche, Near, Cosmos, in fact. So the Cosmos Hub, we were talking a lot to the Interchain Foundation. And then in the end, me and Fabian kind of decided that, hey, listen, instead of kind of building it out custom per blockchain, although that is nice for a few use cases, what we can do instead is that we're not actually solving a problem if it's just a script that's run by some centralized entity, right? And it's much better if we kind of decentralize this into our own data validity layer. And so that's when we kind of, after talking to a lot of other blockchains, kind of decided that this was the best approach. And so we started building out our own network. And 2.5 years later, here we are, just launched our mainnet.
That's a pretty compelling story. I'm curious, you guys launched as a sovereign chain. You've got 100 validators on your network. Were you at all thinking about, different choices of how to build your app chain inside the Cosmos ecosystem? Because now it seems Cosmos is posed for choice, right? There's Dimension. I guess Saga wouldn't be a good fit for you guys, but you could also be a consumer chain. You could leverage shared security. Have you guys gone into any of these ideas, or was it always just like we want to be sovereign?
Yeah, so maybe it's also good to kind of give you some context about how we started. So we never actually started as a layer one, like an app chain. We actually started as a smart contract. So we've gone through three different iterations. The first was an Arweave smart contract, which, albeit was good at the time, definitely did not scale to what we needed it to. We were very early into the smart contracting layer is called SmartWeave. So we were very early into the SmartWeave ecosystem, for lack of a better word. And so obviously just like wasn't a right fit for us. So we migrated over to EVM. That was great, but with many things with EVM, you kind of have to do two things, which is one, optimize for gas, which is a pain when you actually need to store vital information on chain. And so you're always fighting to kind of bring down gas as much as you can. And then the second problem as well is like, even if you bring down gas, like completely optimize your smart contract, the problem is that you're competing for block space with the rest of the network, right? And so actually it was at ETH Denver 2022, when we decided, hey, listen, we're working a lot with Cosmos. We've seen a lot of the good benefits that, the app chain thesis has. And so we actually just, while we were at ETH Denver, we actually just hacked away like a KYVE implementation, but using the Cosmos SDK. And then, yeah, kind of ever since then, we just really saw that that was single-handedly the best future for KYVE. And yeah, we went from there. Regarding, like a roll-up or shared security or anything like that, regarding a roll-up, personally wasn't that attractive to us. Also, kind of the roll-up space in Cosmos also matured a little bit too late for us after we were kind of a long way into development. Regarding ICS, interchain security, and replicated security, which I believe is like the V1 of that, this just launched. Again, kind of similar thing there. It's like we were already kind of too late into the development process to kind of get that kicked off there. And yeah, I think like for now, I think the best approach for us, because we have to kind of have like very high security, we just kind of decided to go with our own validator set and our own app chain.
So what do validators actually do? You guys must have developed, I guess, some custom modules. Are validators in charge of actually retrieving blocks from these other blockchains and then, coming to consensus on what the block is and then storing it? Or can you describe what happens outside of the regular transaction processing?
Yeah, exactly. So this is probably a good time to kind of talk about the architecture of KYVE. So basically, until vote extensions get released in Cosmos SDK Eden, which I believe is V0.50, which could be a while, but until vote extensions are a thing, what we decided to do is, of course, there's no way of really extending the base Tendermint validator, right? And this is exactly what we needed. For example, Acceler has done something similar, but it's kind of like a side process that's running along with the Tendermint validator. So what we actually opted for is we actually have two layers. We have the consensus layer, which is your normal Tendermint validator, just producing blocks, updating state, reaching consensus on that, exactly what the name suggests. And then we have a second layer on top of that. That's our protocol layer. This is a completely unique validator set, but both validator sets use the same token, which is the KYVE token. What's cool is that because we have two different validator sets, we can kind of always fall back on the consensus layer to reach consensus for the second validator set. And the second validator set runs the side process, which then connects to all these blockchains and pulls down the information and then validates it to make sure that it's correct. So yeah, that's kind of the way that the validators work. The protocol validators, they can pick and choose which data stream they want to archive and validate. So say, for example, you want to run a very non-high data intensive validator. So you probably wouldn't want to help archive the Solana chain, for example, or if you have a really beefy setup, then you would probably pick the Solana chain. Yeah, we just basically made it as customizable as possible.
Okay. Is there a minimum set of validators that have to be ingesting a certain data source for you to be able to certify, correctness or somehow that it hasn't been manipulated, or is it starting with one?
Yeah, so this is actually a really cool feature that we did. So each and okay, taking a step back. So the way that we've designed it so that you can archive different data streams or data sources is that very similar to actually Osmosis, where you have different liquidity pools focusing on different tokens. We have data pools which are focusing on different data streams. So what happens is we have a max number of validators per data stream or like data pool, which would then be 50 validators. And then each pool has a value set by governance on creation or whenever it gets updated, which is basically like a minimum delegation amount that basically ensures that the pool is active. So if you have a minimum, like let's say, for example, you have a delegation amount in the pool of 1 KYVE, then of course that's insecure and you're not going to start archiving. So normally this value is set to, something a little bit higher, like 100,000 KYVE or something like that. And the cool thing is that as validators join the pool, archiving will not, kind of start off. The pool will still be in like a quote genesis state where there's no archiving happening until we reach enough validators with a total delegation of 100,000. Also, this is just a number. This is not actually the mainnet value.
Right.
And then what's also cool is that like once archiving actually starts like to happen, the other cool thing as well is that let's say, for example, a validator leaves a pool, the archiving would immediately stop, opening up time for another validator to kind of come in and fill that gap. That way we kind of maintain optimum security. Now, the thing is like for some data streams, maybe for whatever reason, the developers of that data source don't actually need high security. I mean, it's always recommended to have a very high minimum delegation amount in a pool, but that can technically be lowered a lot more in case you want to like speed up the archiving process, or it can also be hired much, like it could also be raised a lot higher to then also improve security.
For a validator joining a let's call it, you call it a data pool, is that permissionless? They can just if there is a slot,
completely
permissionless. They can come in. So in some sense, you guys have created a market for these data streams. So I, as a validator, can, as an interested party, I can delegate to the pool, and then I, as a validator, can look for a pool that has, let's say, the highest value, and then just participate in this.
Exactly. So the way that it works is the more people that want the piece of data archived, the more they'll actually pay for it. So it's like a pay to archive model. And so of course, you as a validator, if a lot of people are paying to archive Solana, then of course there's going to be more competition on the validator side of things on the Solana pool, for example. So yeah, no, exactly correct.
Okay. And I'm guessing the validator, if the validator was trying to supply or somehow modify the data in flight and this was discovered, that's a slashable offense. I'm guessing that's why the delegation has to be high, because then the slashing penalty is incentivizing honest behavior.
Exactly. Yeah, exactly. So very similar to Tendermint consensus mechanisms. We actually have very similar like slashing downtime for invalid, I guess, data archiving in this case. So it's slightly different than Tendermint, but it's very similar slashing mechanisms, exactly.
Okay, I mean that's it's a pretty interesting infrastructure construction. Do you guys have a white paper or something where this is detailed out? Because I've seen the web page where there's this very high level of architecture of there are validators, or there's a storage backend, but these are interesting details. Are these discoverable somewhere? Do you guys have a good book or some other docs?
So yeah, so we definitely have we have docs.kyve.network, which kind of has always has the latest version of the architecture. We do have a light paper on our website actually, but to be honest, that's from a long time ago. And since we've been heads down, like really heads down. Yeah, we've been really heads down on developments, and now that mainnet is out, we are going to be working on like an updated, pushing out our first white paper. So definitely stay tuned for that. But until then, I think our docs would probably be the best place to kind of start, just kind of looking at the architecture. Because also there we explain a lot about all the uniqueness of the protocol layer. Because a lot of the times I compare it to Tendermint a lot, but it's very unique and it has a lot of interesting design choices that we've made for sure.
Right, right. Um, that's if we now think of the, or actually before we go to how to start, I'm curious. We've discussed blockchain data. Are there other types of data that you guys are going to ingest and to make available? I don't know. I'm thinking like weather data or historical pricing data, stock market data. Are there any types of specific um, um, data that you want to have on they want to have an index or store?
Yeah, for sure. So yeah, so like of course like for now and like the reason why we got started is historical blockchain information. But we built it because, of course, we had to remain fairly agnostic because of all the different blockchains that we archive. We actually made it so agnostic that you can actually archive Web2 data. So exactly like you said, anything from, pricing information, stock prices, historical versions of those, to even like we've partnered with Say Network to archive and like validate sport bet information as well. So it's like, or even like weather information as well. It's like there's a wide range of data streams that you can access via KYVE. Basically, any data stream that's actually deterministic, because of course you can't validate something that's not deterministic. And I mean, of course, we can argue what exactly is deterministic when it comes to Web2 data. But like overall, any data source that is deterministic and can be like easily verified can be archived through KYVE. No worries.
So if I now think of the other side of the equation, right? Let's say I'm a consumer of the KYVE data. Let's not restrict ourselves to specifically blockchain data, but let's say I want to use that weather data or something. How do I get started using KYVE, right? I mean, KYVE stores this data, but then what if I want to do something with it? Where do I begin?
Yeah, so the easiest way of fetching data from KYVE right now is through our ELT pipeline. And so yeah, so we've partnered with Airbyte, which is a very popular tool in the Web2 ecosystem, actually, where you can kind of consume data streams into any traditional database that you're normally used to working with, which gives our customers kind of like the most options, if you will. And so like that's the easiest way to kind of get started using KYVE data right now. Long term, though, we're going to also kind of be bringing an on-chain query method via an oracle, where not a traditional oracle where you can only fetch pricing information, but basically an oracle where you can fetch all of the data that KYVE validates and archives through IBC using interchain queries. And then that would be paid via either by KYVE tokens or any other governance white label token as well.
Right. So if I think of it as a data scientist, let's say I have some favorite tool that I've got like Airtable, and I'll hook that up via your partner Airbyte, and then that I can pull into my table or into my Snowflake database or something a certain set of records. Like I can there's some sort of query language that I can use to delineate like a part of the data stream and then pull all that in.
Yeah, so the way that it works and what's really cool about Airbyte actually is the fact that what you do is it's really easy. You just say, okay, listen, I want to use the KYVE connector. Connectors is what it calls when you want to ingest something. So I want to fetch information from KYVE. And then you could just specify which data pool you want to fetch data from. So if you are interested in, I don't know, near information, Cosmos Hub information, and Solana, right? I don't know, weird aspects of data, right? But let's say that you're interested in like those three data pools, then what you would do is you just simply specify those. And then before ingesting it in Snowflake, like you mentioned, what you could really easily do actually is you could do any transformations that are needed on that data as well to better suit your needs. And that's really easy through Airbyte as well. I think you just write those transformation scripts in Python, which is like a widely known language. And so it really allows you to easily transform all of the data to exactly what you need.
So how does the pricing or the usage sort of metering work? So obviously there is payment for storage, right? I mean, Arweave has this sort of permanent storage model based on staking AR. Do you guys somehow magically transform KYVE to pay for the AR on the back end, or do I have to worry about any of that?
No, so like as somebody using data on KYVE, you don't have to worry at all about holding Arweave or anything like that. The only thing that you need to worry about is, of course, having KYVE tokens. So like until we launch our Oracle product, which should be coming out very soon, the way that you actually like access, the integration with Airbyte is actually we have a funding-based model where basically if you want the continued archiving and validating of a specific data stream, you then actually need to put KYVE forward as basically like a down payment. And then that KYVE is then slowly distributed as more and more bytes and gigabytes and terabytes, even in the case of Solana, is then archived and validated. And then basically that's exactly how kind of the incentivization model works, is basically the people using the data first kind of make a down payment in KYVE that slowly gets trickled down to the validators and the delegators in the pool. And then of course that's like the entire incentive model in place.
So, but that is reading the data free then? Like, can I extract data from can I ask, are we for a blob? Or like, is that metered as well?
So you can always ask, are we for any information that we've like permanently stored there. The only thing though is that it's never guaranteed. So, okay, of course, like, you is just like a personal person, like let's just say that you want to just fetch a random block using KYVE, right? Like, of course you can do that, right? But like if you are, a company building a product or somebody like really relying on this data, of course, there is no guarantee that people are going to still pay for the data for you, which is why, it's always like, it's basically incentivizing you as a person that's like actively relying on this like data still being archived to then go in with your KYVE tokens and fund this process.
Right, but you'll be funding the storage of the data, the ingest, just to make sure that the data is there. But then you're not charging me for actually reading through that data. And so I'm asking because this would be a really huge difference to me using something like Amazon, where egress costs are massive. Like these guys don't want the data to leave Amazon, right? So that's why if I'm thinking about extracting terabytes, it would be a huge difference for me as a user if I could access the KYVE network. And once I've paid for storing the data, I could then ingest it, only pay for my Snowflake usage, but not for moving the data.
Yeah, so exactly. So the thing is like once you've paid for like the validity process of the data, everything else is completely free for you. So then you can just like really easily access it. I think like when you're fetching terabytes of data, then I think you then need to kind of talk to the Arweave team and then see the best way of fetching terabytes directly from Arweave. Definitely might be like a slow process, but I think it's going to be always slow fetching terabytes of information. But exactly, you don't need to basically pay twice for this data. You only need to pay to incentivize the network to validate and then archive the data. Then once it's at that point, you can then just really easily access the data. The on-chain process, the Oracle service will be paid, but it'll be like significantly, and like it'll be a very insignificant charge per query. I mean, okay, it's going to be based on the number of bytes that you're retrieving, of course. So please do not try and fetch terabytes worth of data on chain. But like
interchain query, just clog the channel.
Interchain query,
I get that. But that's actually, that means you're processing query. Like this feels like a different model, right? That means you're already sort of like, I'm writing a specific query, you're processing the data on your end. So you're also contributing not just storage, but also some CPU time to actually get me my answer, right? Which does feel like a model that it makes sense for me to pay for that query because I'm also offloading, CPU processing. But what's exciting to me, if I go back to this, is like, it doesn't feel like you guys are locking the data in, right? I didn't understand that when I was looking at the project, that if it's actually true that I can retrieve a part of that data and I don't have to pay for it, then it feels like really you guys are like storing and then liberating the data instead of storing, closing it in, which is the current business model of basically everybody else. So that's a really cool thing. I just want to point that out, that it's definitely non-standard.
Yeah, no, like that's exactly what we're going for here. Basically, it's like we're trying to incentivize everyone in the network, but at the same time solve all the problems with like the traditional way of fetching the information. Because otherwise, if we're the same, if not worse, than the traditional model, then people aren't going to really care about the validity of the data. Because at the end of the day, costs kind of add up, and if it's exactly the same as using Infra, a bad example, but you get what I'm saying, is basically like if it's just the same as your like current solution, then of course nobody's really going to care about data actually being decentralized. So exactly like you said there, and that's actually a great thing that maybe we should highlight a little bit more in the public, actually, is the fact that it's like, yeah, we actually your great terms is actually like we liberate the data, right? Where basically, we take it, we incentivize all the actors in between so that we can actually guarantee that it's economically, validated. And then after that, it's just completely open and transparent for anyone to access.
Which brings me to a sort of converse question. It's obviously like a whole different thing, but I got to ask, is it possible for me to sort of store data in some encrypted fashion where, I can consider it private and then, it's retrievable only for me? Is that something you guys are thinking about as well as a special case, or is this not what the network is suited for?
So encrypted data is definitely something that you can do. Like just in general, like public key encryption is super easy, and like the way that you actually retrieve data streams, like the way that you actually code how you retrieve data streams would allow for this. The thing though is that at the end of the day, if you're the only person, like if it's your data stream, you're the only person paying for it because you're the only person that can access it. It doesn't really make a lot of sense. Which is like why a few networks where basically, I think, for example, like a lit protocol, for example, there's like a lot of other examples out there, but that's just like the one off the top of my head where basically they allow you to decrypt data based off of like a certain requirement. For example, if you have 10 KYVE tokens in your wallet or something like that, right? Mm-hmm. That would actually be a really cool use case. And that's actually what we're more interested in on like the encryption side of things is basically, hey, listen, we want to encrypt the data to, maybe remove any free rider problems or anything like that in case anyone's worried about that. But then like there's certain requirements. Either you've had to have funded this storage pool process or anything like that. And then the network could then decrypt the data for you. So definitely possible, definitely something that's kind of like on the roadmap, not a huge priority though, but definitely something worthwhile. But like regarding like private data, personally probably wouldn't recommend it that much unless it's kind of like more of a not that private, like personally private, but more like corporately private or something like that. But yeah, like if you're just storing like photos or something like that that you want to encrypt, like no.
It definitely feels like it's geared toward a use case where you store a set of widely useful data one time and then you make it useful. It definitely feels like that is the mainstream use case. I was just wondering whether it would be possible to say misuse the network to sort of. So I'm getting it. It's not really. It is possible, but not really recommended, and it doesn't seem to be really useful.
Yeah, it's possible, but at the end of the day, you're just going to actually be spending more money. So,
which
like, it's kind of more of a burden on your guys' side.
Which brings me to the question of returning to, let's say, these use cases or partnerships. Like, is there, do you have any other use cases in mind that you particularly would like, to see KYVE used for? That are engaging to you, and you feel like, oh, that'd be great if somebody put that on KYVE.
Yeah, that's quite interesting. So yeah, like I mentioned, like partnerships wise, we partnered with the Airbyte team that kind of covers the Web 2 sphere. I mean, Web 3, and this is like all public knowledge, but we're backed by pretty much every single layer one that we've integrated has like, not personally, but like they themselves have actually like invested in us as a foundation, which is really cool because then it's like incentives are aligned on like everyone's side. And so like, of course, like, partnerships and use cases would be kind of aligning now that we're aligned with a lot of those networks, kind of finding like data rich integrations into their ecosystems. For example, like Near wants to like eventually use our data to completely sync a full node of Near, like in a completely trustless way without needing any third party snapshot provider or anything like this. Right. This is actually something exactly. Yeah. This is actually something super interesting in the Cosmos space actually. And we're partnering with like a lot of big name validators right now, actually, because they have the problem where they can either sync from Genesis or they can trust another validator, which might raise a few question marks with a state snapshot. And so actually what we're working on like internally right now with a lot of validators is actually coming up with a tool where basically you can like state sync Tendermint directly from a KYVE data pool, which is really cool.
Right. Yeah, that's a really cool use case. Doing this trustlessly without relying on a particular state snapshot. So if we think about the roadmap now, so the use cases that you described encompassed two basic use cases with data. One is to store it, And the second one is make it available for an ETL pipeline for the extract, transform, and load process. Are you guys so you've mentioned the oracles where I can already also query the data, right? So it's sort of there's no ETL step, but I'm actually directly querying the data and getting some answers. Are you guys thinking of also building out like a compute capacity that will be more general purpose, meaning I can connect to a cluster of nodes and just those can process KYVE data for me? Is that something that's on the roadmap, or not necessarily in
Not
scope?
something Not something that we've thought about for now. Like right now, we're focusing on bringing ELT kind of out of beta, like bring that to like full fruition, and then also of course the Oracle. Like the Oracle is like not actually something live yet, but like we love talking about it because it's
Yeah.
definitely like the next big thing for KYVE for sure. Is kind of like being able to query this vast data set on chain is something really exciting for a lot of people, especially in Cosmos. Um, and so yeah, so like of course like those are kind of our biggest focuses right now, but of course long term ideas like that are always welcome, for sure.
So is there anything else you can mention on the roadmap besides the oracles that's coming up?
I think actually I've mentioned everything throughout the call because it's just like, yeah, it's like I always save those for like the ends, like those little bits of alpha, but to be honest, it was important to kind of mention those prior. I think, yeah, definitely keep your like eyes out for the Oracle product. That's definitely going to be launching within the next few months. I think, yeah, overall, we're definitely gearing towards like our first data pool on mainnet, which is super exciting. And it's definitely going to be a Cosmos one because we really want to launch with the initial use case of being able to state sync a Tendermint node directly from KYVE in partnership with a lot of validators and other organizations. So yeah, I think that that's like something like very soon on the roadmap that people can kind of keep their eyes peeled for. But yeah, definitely the Oracle. I think that that's something I'm really excited for.
Right. So if people want to connect with you guys, do you guys have a Discord server? Where can they find you?
Yeah, so we have pretty much everything in existence. So we have a Discord server, we have a Telegram server. We are launching a Commonwealth very soon. I think we have a forum still currently up, but then we're launching a Commonwealth very soon. We have GitHub, we have an email. Yeah, we have pretty much everything. But all that you can find on our website, kyve.network. All is available there.
Perfect. So people know where to find you. Well, thanks very much for chatting. This was really cool. I enjoyed that.
Thank you so much.